Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Today's essential question is, how does friction impact on objects' movement? Friction. It's a force that holds back the movement of a sliding object. A force is a push or a pull on an object. But that's it. Friction is just that simple. Friction is caused by differences in the surfaces of touching objects. If friction did not exist, a moving object would never stop. It is important to remember that only when friction is present does an object need a force to keep an object moving. You will find friction everywhere that objects come together and they touch. Each time an object comes together or in contact with another object, friction is present. The force acts in the opposite direction to the way an object wants to slide. If a car needs to stop at a stop sign, it slows down because of friction. The friction between the brakes and the wheels and the street. If you run down the sidewalk and stop quickly, you can stop because of the friction between your shoes and the cement. If you had dress shoes on, you would have less friction. You may not stop as suddenly. You should know the force you exert to move an object is in one direction. The force of friction is in the opposite direction. What happens if you run down the sidewalk and you try to stop on a puddle? Friction is still there, but the liquid makes the surfaces smoother, and therefore the friction is less. Less friction means it is harder to stop. Low friction happens when it rains. Cars have a hard time stopping. That's why there are so many accidents. Even though the friction of the brakes is still there, the brakes may be wet, or what happens in the case of what is called hydroplaning, water forms a barrier between the wheels, the tires, and the street. And therefore it's harder for the friction to stop the car. If a car is going at a slow enough speed, the hydroplaning will not occur. But if the acceleration or the speed is too fast, the car will not be able to stop, and an accident will occur. What are some causes of friction? No object's entirely smooth, but you can see different surfaces like an emery board, what you use to file your nails. You can compare that to the tabletop of the desk that you're sitting. They're completely different surfaces. But yet your desktop is not completely smooth. there are still tiny little bumps that will cause an increase in friction, especially if you're using a different surface area, such as a rubber-based tape dispenser. You'll notice that it's harder to push the tape dispenser because of the friction. The two surfaces that are different act as objects going in the opposite direction. Therefore, you can see how it's harder to push a rubber-backed tape dispenser versus your textbook that does not have a rubber back. The other main source of friction is what all objects are made of. All objects are made up of atoms and molecules. No matter what type of the surface an object is made of or made up of, consists of atoms and molecules. These atoms and molecules are extremely small particles that contain a weak electrical charge. When the positive charge on a certain type of surface comes in contact with the negative charge on a different surface, the result is attraction. When two objects attract, they tend to stick together. Remember, it is important to remember that attraction is the other main form of friction. Another type of friction would be fluid friction. Fluid describes anything that flows. With fluid friction, just like the other forms of friction, there are opposites of the objects that they are in contact with. The only difference in fluid friction is that one of the objects must be one of two things, a liquid or a gas. In the case of a gas, what is happening is the solid object gets resistance from either the gas or the liquid. This doesn't involve sliding surfaces like friction does, but instead it's the kind of resistance you get from trying to push your way through a crowd. It's a collision situation, but not a sliding one. If the gas is in the air, this is referred to air resistance. If you were to jump out of an airplane, you would feel the tremendous air resistance. While gravity is pushing you downward, air resistance is pressing upward. We experience a similar feeling if we were to stick our head out of the car window while driving fast. I'm sure you've seen dogs do it, and you probably don't understand how they can still have their tongue sticking out and not lose all their saliva, but they still tend to stick their head out the window and you can see their tongue going to the side. The car that's moving forward gets that air resistance if your head is sticking out the window. Although liquids offer resistance to objects moving around them, they can also smooth surfaces and reduce friction. Liquids tend to get thinner or less viscous as they are heated. Yes, that's like the viscosity of oil you put in your car. Car engines have a lot of moving parts, and they rub together. The rubbing produces friction, and the result is heat, which would be bad for your car. That's why you need to make sure that there's oil in your car so it produces less heat. And yes, your car will use up the oil, but you need to replace the oil because then you could have your engine seize, and that would be bad. You can measure friction, and there is something called the coefficient of friction, which is how to measure the friction of two surfaces. So concrete has a high coefficient of friction, a higher number, and if you had concrete on concrete, you would see that it would be hard to push those two objects. The friction is high there. You should know that the coefficient of friction is measured on how easily one object moves in the relationship with another. So, do you think the coefficient of friction of ice or you on ice would be high or low? It should be low because it's easy to slide on ice. Scientists have discovered that there's even less friction in Teflon. And actually, Teflon was discovered by a mistake. But they found that the surface was so slippery, and they tried to find an application for that slippery surface, and they came up with, that's right, Teflon pans. Static friction. How many of you have gone to bed at night, especially in the winter, and as I would tell my children, do you see little lightning bolts come out? That's the static friction that you're seeing. There's an amount of force that you see when pushing two objects together. The static friction that you see at night in your bed is different, but there's still a reason why it's called static friction. When you push two objects together, that creates that resistance. When you see those little lightning bolts, what you're seeing is a result of the electrical shock, but the two objects are clinging together. And when you're pulling them apart, you see the result in the charge. However, pulling apart your covers in the winter time and seeing those little shocks and those lightning bolts, that's fine, that's easy to do. But static friction is the two objects sliding against each other, and sometimes it's easy and sometimes it's much harder. For example, if you're pushing a box across, not pulling your covers from each other, that box is going to be much harder to push. When static friction is overcome, the object will begin to move. There is an amount of force required to keep the object moving. This is sometimes called sliding friction once the object gets moving. For an object to move, you must first have to apply the force, more force than the static friction. As long as an object is moving, the sliding friction does not change. You can keep going. The object stops when the force on the object is less than the force of the sliding friction. Friction can be helpful. Without it, we would not be able to walk. You wouldn't be able to drive a car. And yet, with it, we can overheat our cars and seize up our engines. So there has to be some sort of balance. We need to use it to our advantage or compensate when it's too much.
Thank you for joining us on How to Improve Science Performance Through Strategic Note-Taking.